Welcome to our session on building multi-tool research agents, so showcasing how we unleashed Amazon Bedrock's power through SAP GenAI Hub using Strands SDK. My name is Michelle, and I'm a solutions architect at AWS, and I'm joined today by my colleague Abraham, who is also a senior solutions architect at AWS. In this session, you can be excited to be building two agents together with us. But before we get right into that, we will need to do a short introduction on all of the important concepts needed for that, including, for example, of course, SAP GenAI Hub, and also how to use the Bedrock models through it. Then the framework we will be using together today, which is Strands SDK, and we will do a short detour on MCP as well. Afterwards, we will then do a quick setup before we dive right into the code and build agents. Today, we will be building two agents for you. First of all, we build a deep research agent with Tavily API. And then second, we will use the MCP protocol to build a financial intelligence agent with you as well. But let's start right in. So first of all, let's start with where we can access the large language models that we are using to build our agents. For this, we choose to consume LLMs through SAP GenAI Hub. SAP GenAI Hub offers a variety of models that are recommended and where legal and risk assessments have already been completed centrally for you by SAP already. Additionally, there are SAP-specific guardrails and orchestration capabilities available to you. So if you're working in the SAP ecosystem and want to build a GenAI application, SAP GenAI Hub should really be your first stop to do so. But where does Amazon Bedrock come in here? AWS is one of the providers that offers models to Generative AI Hub, for example, the Anthropic Claude family, or Amazon's own frontier models, the Amazon Nova family. So here we can see how this would look like in action. As you can see, you actually use BTP or the BTP platform, where you have the Generative AI Hub. Within the Generative AI Hub, we have the SAP AI Launchpad and SAP AI Core, where first-party SAP hosted foundation models are, and also foundation models that are partner-built and hosted by the partners, for example, Amazon Bedrock. As you can see some examples of models in Amazon Bedrock that you can access to Generative AI Hub, including Nova, Claude, and the Titan models. So now that we have clarified how we will invoke our large language models, let's look at what we will use to build our agents easily. One component to this will be Strands agents. This is an open source Python SDK that helps you to build agents with just a few lines of code. And I will actually show you an example just in a second. It is simple to use and it eliminates the need for complex agent orchestration by really embracing the capabilities of state-of-the-art models to plan, chain thoughts, call tools, and also reflect and reason. The core philosophy of Strands here really shifts the complexity from a hard-coded logic directly into the weights of the LLM, granting the model significant autonomy to determine the agent behavior. This design approach ensures that the agents remain highly flexible and scalable, easily benefit from advancement in the LLM development as well. What Strands implements is called an agentic loop that really forms the core of its functionality here. This means that we have an input and a response, and in between we have this agentic loop, where the model receives a prompt and context, as well as a description of available tools. What the model then does is that it reasons about the task and decides multiple things. First of all, how to respond directly in natural language. Reason and plan a series of steps, reflecting on previous actions, and then, of course, looking at the tools, selecting and using one or more tools. When the tools are selected, Strands immediately executes them and returns the result to the model again. And this loop continues until the task that is given to the agent is completed. But as I promised, we can really do all of this with just a few lines of code. Here you see the kind of hello world equivalent for Strands agents. This agent is very, very simple and really just has one tool, the calculator tool. Of course, we will build something more sophisticated later on, but just that you get an idea about how to work with Strands agents. If you are interested in knowing more, feel free to check out any of these resources here. So what you can expect is us using Strands agents together with the SAP Cloud SDK for AI to build some really cool agents using the Gen AI Hub of SAP. Another concept we will be heavily utilizing, especially when we build our second agent, is MCP. And for this, we want to just do a very short recap of what MCP is. So what exactly is MCP? Think of it as the missing piece in your AI infrastructure puzzle on how to connect external systems to agents. Really similar to how APIs standardize how web applications interact with the backend. But why is it so important and why is everyone talking about it? Well, some of the key features really are, first of all, the integration with external data sources. So MCP enables AI models to access and utilize data from external sources such as databases, API, or even other models. And this integration allows models to leverage the most current and relevant information, which is important for a variety of use cases. Second, enhanced functionality. By connecting to specialized tools and services, AI models can perform tasks and might even be beyond their native capabilities. For example, they can use external tools for data processing, visualization, or even human-in-the-loop feedback. Third of all, flexibility and scalability. So MCP facilitates the development of more complex AI systems by allowing models to be easily combined with other models or other tools. This modular approach really makes it easier to scale AI applications and adapt them to different contexts. And lastly, and even most importantly, I think, is standardization. So MCP provides a standardized way for AI models to interact with external resources, which helps to ensure compatibility and reduces the complexity associated with integrating different systems. And with this, I would like to hand it over to my colleague Abraham, who will walk you through the setup of Amazon Bedrock models in SAP Gen AI Hub.
Thanks, Michelle. Hi, everybody. My name is Abraham Arellano, and as Michelle mentioned, so I'm a senior solution architect at AWS. And now I would like to navigate with you the SAP BTP requirements to run this demo successfully. But please refer the guide on the screen to look into more details for full end-to-end BTP configuration for this project. And here we will focus on initially 4 steps. Check the entitlements or user must have. Then we are going to create AI Core and instance and subscription. And from there, we will get the credentials to access Generative AI Hub. And finally, we are going to deploy our Bedrock model for a specific project. So now let's start with the BTP entitlements for this demo. First, on the BTP cockpit, let's navigate to the entitlement section. In here, we are going to validate that we have at least 2 main services available for us: AI Launchpad and AI Core. Once we have verified that we have those specific entitlements for our user, then we can navigate to the service section. In here, we will find the instance and subscriptions, where we will need to create an instance for our AI Core service. Initially, you will need just to create and select the service that we just took, AI Core. But in our specific use case, we don't need it because we have already created beforehand for this specific demo. So now what we need to access is the instance, and on the service binding, we will find these 3 dots. Once we click here, we will have the option to download a file that contains the credentials that will later on will help us to access Generative AI Hub for SAP. Now, once we have this credential, let's focus on how to deploy the Bedrock models. And for that, we will need to access to the SAP AI Launchpad. In the SAP AI Launchpad, what we need to navigate is to Generative AI Hub, the model library. In here, we will find a huge catalog of all models available for SAP Generative AI Hub. In our specific case, we will filter for Anthropic and we will select Cloud Sonnet 3.5. We know that right now has been deployed already Cloud Sonnet 4.5, but we will be using this just as an example. And then we will click deploy. Once we are deploying this, initially it will be automatically be able to be used. But to verify that, we are going to navigate to ML operations. And then on the deployment section, we can see that we just have started and kick off this new model. We will wait a few minutes and then it's going to be ready to be used. Now with that, back to you, Michelle.
Great. Thank you, Abraham. So now that we're all set up, let's start building agents. And for that, let's look at our first agent that we're going to build together, which is the Deep Research Agent. Here's the architecture of how this will gonna look like. As you can see in the introduction, we already talked about some of these concepts and some of these building blocks. And here they all come together. So first of all, we have our users who will interact with the AWS Strands agent. The AWS Strands agent will use an LLM, which is the Anthropic Claude model, especially the Anthropic Claude model Sonnet 3.5 that Abraham had just deployed. We will then use this through the SAP GenAI Hub using the credentials that also Abraham just showed us how to actually get from our BTP cockpit. The architecture that ensues here looks like the following. So we have the AWS Strands SDK, and this will orchestrate the different tools with the LLM to get the agentic loop. We here have 4 different tools that we're using, and we will go a bit more into detail when we look at the code here. Semantic search, context extraction, deep crawl, and lastly, format response. 3 of these tools will be using an external API called the Tably API services, which really helps us to do a web search, content extraction, and deep web crawling. And all of this is orchestrated in a way to result in research reports or analysis brief, just in the format that we want to know from our deep research agent. So let's go and look at the code. Perfect. So you should all be seeing the deep research agent built with Tably API here. So this is actually a tutorial that you can also access through GitHub or a workshop that we have published. And we will share these resources at the end of the workshop with you if you want to go and follow along. Also, if you want to have a look in kind of the details of how we actually use the credentials that Abraham has showed us how to get from the BTP cockpit and the SAP Cloud SDK for AI to get to the Amazon Bedrock models in SAP GenAI Hub. But so first, let's get started. What do we want to build today? We want to build our own deep research agent that can connect to the web for up-to-date research and then orchestrate these different tools to actually give us a report in the format that we wanted. And to do so, the first thing that we have to do is actually sign up for Tably at app.tably.com. So we can get an API key that we will use in our API calls later on and also in our tool use. For this, I've actually already done that. And I copied the API key and put it in our .environment file. If you haven't done so and want to follow along, please complete these steps first. Then we have to do some setup. First of all, we need to install all of the SDKs and all of the libraries that we need. So this includes Strands Agents, Strands Agents Tools, Strands Agent Builder, and then, of course, the SAP SDK, Cloud SDK for AI. So let's just wait for a second until this has finished running. What we also need to do is set up our Tably API client. So we can actually later on call the different methods that we want to use here for our tools. And let's just also quickly do that. So before we go further, let's just again have a quick look at a more simplified architecture of what we're going to build today. So we're using Strands Agents for the agent orchestration, and we're going to do so in our local environment. So we're going to run this here in our Jupyter Notebook. We will define 4 different tools that have different abilities, including web search, web crawl, web extract, and format research response. 3 of them, as you see here, will be using the Tably API. Then we also have our deep researcher agent that can use any of these tools, but also an LLM. And it does so by using an Amazon Bedrock LLM through SAP GenAI Hub. So in the first step, what we need to do is define our language model. And we will do so here, defining this as a model. What we have done here is that we use a utility function that we have also defined in this workshop, the SAP GenAI Hub model object, to do so. Under the hood, this will be using the credentials that Abraham showed in the second step, as well as the SAP Cloud for AI SDK to then access the Anthropic Claude 3.5 Sonnet model through SAP GenAI Hub. If you want to look at the details of this implementation, feel free to check out the GitHub repo, which will walk you through the steps, and you can have a look at the utility function and all of its implementation here. For the ease of this tutorial, we have abstracted this away from you. So after we now defined our model, what we still need to do is define our tools. And what we have here is 4 different tools. So first of all, let's start with defining the Tavily search tool. And to do so, we want to bring the format of the response from the Tavily API in a format that aligns with our agent and helps our agent to really have a well-structured response that can work with. As you can see, this is really just doing some formatting, result, title, URL, and so on. Now we actually get to the tool definition. For this, we need to use the add tool decorator, which will make this function available as a tool to our agent. We call this function web search as it uses the Tavily web search API. So in order to do so, what we actually do is that we call the Tavily client with the search function, and we then use our formatting method that we have defined before to format our results and give them back. Let's just run the cell real quick before we go to the next definition. Very similarly, we also define the Tavily extract tool and the Tavily web crawl tool. As you see again, we have a helper function for formatting our results, and then we use the add tool decorator for our method that can then actually call the Tavily API extract, as you can see here, formats the results, and returns the results. Let's also run this. Very similarly, again, we do the same for crawling our results. In this case, here we have the helper function for formatting. And then here we use the tool decorator to call the Tavily client crawl and then actually format our results. So for the fourth tool, we're doing a bit of a different approach. And what we do here is that our fourth tool is actually also its own agent. It is going to be a sub-agent that our main agent will have access to as a tool. As you can see here, what we need for this is first a system prompt. And the system prompt we define here, we're going to call research formatter prompt because we're giving it all of the instructions for formatting the research response. As according to some best practices, we're going to give it a role, telling it what its role is. Your role is to transform research content into well-structured, properly cited, and reader-friendly formats, is what we're going to tell here. And then we give a set of rules that always need to apply and that it needs to carry out. Then, because it's going to be a tool, we will again use the add tool decorator for the function where we actually define our tool. But besides only calling an API, what we do here is that we define an agent. So we use the Strands agent SDK and the agent object from it to actually define our agent here. For defining our agent, we only give it a model, which is the model that we defined in the very first step. So this will be calling the Claude 3.5 Sonnet through SAP GenAI Hub and Amazon Bedrock. Secondly, we give it the system prompt, which is the research formatter prompt we just defined in this very cell. As you can see, this agent does not have any tools whatsoever. So it's a very simple sub-agent that only has access to a model and some instructions that we give in the system prompt. Let's also run this cell. Now we get to the main agent. And for our main agent, we also need a system prompt. So similarly to the other agent, we define this here, giving it a role. It's an expert research assistant. We also give a list of tools, including all of the tools that we just defined, and some rules it should always adhere to. So now let's look at how our agentic loop looks like right now. So we have the input and context here, as well as the response. And this in the middle is our agentic tool, meaning that the LLM that we use here is Claude 3.5 Sonnet and always goes through this loop looking at, is there any of the tools that I can use or have to use to get the answer or complete the task that I was giving through my input, and going through this loop as long as they have the final response. Here we now get into actually defining the agent. And to do so, what we do is that we say we want a deep researcher agent, again, using the agent object from the Strands Agent SDK. As you see before, we also define the same model. We're also using Claude 3.5 Sonnet here and the system prompt that we defined. But in a difference to our previous sub-agent, we also give it access to a number of tools, which is the 4 tools that we have already defined before. So let's run the cell as well. So let's test the agent. Let's go back to the research prompt here. The research prompt is what the SAP Concur end users need SFTP for usually. And I actually don't know this answer, so let's see what our own deep research agent comes up with. So first of all, it helps us summarize. Okay, so I help you research how SAP Concur users typically utilize secure file transfer protocol functionality. And it creates a research plan and gathers information to do so. So with the research plan, it's giving 4 steps. First, researching general information about SAP Concur and SFTP usage, then looking for specific documentation, identifying common use cases and scenario, and then format the findings into a clear, structured response. Then it tells me the steps that it actually takes and the different tools that it uses to do so. And as we can see here, it uses 2 different tools actually from the tools that have available. So first of all, a web search using the Tably API or a general web search, then another web search for more specific use cases. And then, since this has been already enough information as it seems like, formatting the research response. So as you can see, it here goes to the agentic loop multiple times. And then we get our report, which is a technical report, including an abstract, key finding, and a conclusion, as well as some sources that we can check out later on. So as you can see here, the key findings are around, okay, can be used for enterprise resource planning integration, data exchange operations, and so on. I will not walk you through the details here, but now you have successfully built your own deep research agent and can ask all the questions that you are interested in. And with that, I would like to hand it back to Abraham for the second agent that we will build today.
Thanks, Michelle, for that great demo. Now we'd like to switch a slightly different technology. MCP, Model Context Protocol. And if you haven't heard of MCP before, don't worry. It's relatively new, and today I will show you exactly what it is and why it is useful for building AI applications. But more precisely, I want to show you how MCP helps you build AI agents that can actually coordinate across multiple services, something that has been pretty challenging until now. And before we dive into the code, let me show you what we are building today and how it's slightly different from what Michelle just presented. So this diagram illustrates our financial intelligence agent, and I will walk you through all the flow. So first, we have the MCP. So you have to imagine MCP as a universal remote for AI. Just like your remote control is able to control multiple devices from across the room, our AI has built-in clients that can instantly connect to any digital service, not only locally, as already displayed, but also across the internet as external services. So as step 1, our enterprise user asks complex financial questions. As a step 2, then this reach our AWS Strand agent, which is going to be our smart coordinator. And it combines AWS technology with SAP AI Hub that also bring us Claude's powerful reasoning. When you ask complex questions, this agent automatically figures out which tool it needs and orchestrate everything. We have already seen that with Michelle. But now our universal remote analogy comes alive. The agent needs tools to work, as we already saw, but those live on specialized servers outside of local ecosystem. So for that, we are going to build a session manager that keeps all connections ready. So think of it as keeping the remote battery charged so every button works instantly. So our system connects to these specific servers, and in our specific case are going to be 3 focus servers: financial data, document analysis, and risk analytics. And each does one thing exceptionally well. So these services works together seamlessly to produce basically investment reports, risk assessment, and comprehensive analysis. Let's jump into the code and understand exactly how this behaves. Okay, let's start first with a problem statement. Some of you probably work with financial data or you have financial customers. And now with AI, you are thinking about using it to process real-time market data, analyze documents, calculate risk, and generate reports. But all of these work together. The challenge is that each of these systems usually live outside your local ecosystem. And the traditional approach is to build one massive application that does everything or write tons of integration code to coordinate between systems. Today, I will show you a slightly different approach with MCP. And instead of creating one big big service or multiple microservices, we will focus on an agent that it is capable to coordinate all these different tools outside of our ecosystem and generate all these different outputs that we are looking for. And for that, let's look a little bit into the architecture. We are going to create 3 MCP servers. These are going to be focused on, first, financial, real-time stock data, company fundamentals, basically market news of a company. Then we are going to have the document analysis server, which are going to do financial sentiment analysis, earning call proposed processing. And finally, we are going to have an analytics and reporting server, which is going to do advanced charting, portfolio analysis, and of course, generating a final report. So let's start and jump into what exactly we need to make this happen. Initially, we need to install several dependencies, but mainly we will focus on the Strands agent, as we already did for the previous demo. And in this case, we are going to also bring the Fast API component. So the Fast API is a framework that helps you to build modern web APIs. This is a robust and already proven system to do it. So we are going to start with this approach. Let's bring all these dependencies that we need. And once we confirm that, we can jump to the next step, which is basically bring our SAP Generative AI Hub dependency, which is one of the most important. But together with that, we have also our MCP client and our agent that are going to be key during the whole process. Now that we have imported all these packages successfully, let's start creating and navigating the first MCP server. And for doing that, this is going to generate stock quotes, as we already said, the company overview, and also we are going to calculate the financial health of the specific stock that we are analyzing. And we are going to be looking into some specific stocks here. But if we look into the code specifically, we can see that the Fast API instance is being created at the beginning, but then we are going to start defining the specific tools that we are going to expose with the server. Get the stock quote, get company overview, and calculate financial health. Those are the 3 tools that will be exposed. And the way that is going to be invoked is through the execute tool method that is going to be defining which tool are we trying to invoke now, whether it is the get a stock quote, get company overview, or last calculate financial health method. After that, we are going to generate this specific file that is going to be our financial MCP server, and we are ready to start it. And this is basically standard code to run an MCP's Fast API application within our Jupyter notebook. But immediately after we run it, we can see that the server is up and running and ready to be used. Now let's jump to our document analysis MCP server. This server handles document processing, but in this case, we are using Fast MCP framework, which provides a simple decorator-based approach for building MCP servers. And here we are focusing on 3 specific tasks: parse financial PDF data, analyze financial reports that execute advanced sentiment analysis with confidence scoring and risk identification. And then we are going to extract key metrics also from all the different information that we have, looking into pattern matching extraction capabilities. Again, if we look into this specific code, we can see how we instantiate the FastMCP framework, but differently from the previous way of doing with FastAPI, now we have some specific decorators that clearly define which is going to be the tool that we're going to expose. In this case, we are going to have 3 specific tools exposed through this method. And finally, once we are sure that this is the exactly definition that we want, then we can create again or a specific Python file out of this definition. Now we have the document analysis server MCP ready to be started. The start of the FastMCP is slightly different. We are going to see a nice banner that is going to give us the security that the server is up and running. And finally, once we validate the specific logs, we see that the server is also up and running. Next, we have our analytics and reporting MCP server. And here we are focusing on 4 specific tools that we are going to expose: create comparison charts, calculate portfolio risk, generate financial reports, and of course, creating a trend analysis of the full time series forecasting. Let's look into detail. Again, we see that the structure is pretty much similar as our previous MCP server using FastMCP. Therefore, we are going to expose all these different tools through these decorators. Once we have created this specific analytics reporting Python file, we are ready to start it. Again, we are going to see the banner that is going to help us to navigate the status of the server. And finally, we have a quick summary stating that all the different servers are up and running successfully. Now for section 2, we are going to build the AWS Strand agent for our architecture. And this is basically where we need to start initializing our SAP Generative AI Hub. Here, we are going to define our model as we deployed before initially on the SAP AI Launchpad section, or Anthropic Cloud 3.5 Sonnet. Once we have initialized this specific component, we are ready to create our MCP Session Manager. The MCP Session Manager is the one that is the component that is going to allow us connect to all these 3 different MCP servers in a seamless way. So we don't need to take care on all these specific connections, keep them open, and be ready to be used by the agent later on. For that, we need to define all these different MCP servers that we have created, and we are going to start these sessions for each of them. That's the task of the MCP manager. Once we have that, we validate that all the sessions are up and running. And as we can see here, we are confirming that all these services are being connected by our clients without any issue. Now let's look into how we can check that all these different tools are being used successfully. And for that, we are going to test each of these specific tools one by one. In our specific section, we are going to create the financial expert prompt. So what we need to do is to define how the agent is going to behave, what the agent role is going to be. And for that, we are stating that we want this agent to be a senior financial intelligence analyst that is going to have specific core competencies across all the different analyses. At the end, the most important part is that the agent will be generated with these 3 components: the financial model that is coming from the SAP Generative AI Hub, the financial tools that have been collected by the MCP Session Manager, and finally the financial expert prompt that is defining the overall system prompt for the agent to understand what their main role is going to be. So once we define this part, we understand that the agent now is capable to access our 10 different tools. And it is being distributed by all these 3 different MCP servers. Now we are ready to do a validation of this integration. So for that, on section 3, what we are going to do is to start defining 3 different queries. Those queries are going to ask the model or the agent to please select the right tool to answer these specific questions. And for that, we are going to start with what is SAP current stock price. Then we want to do an analysis sentiment on this specific statement, which is revenue increase 50% with strong growth. And then finally, we want to do a trend analysis for the SIP stock over the last 12 months. So as we can see, the code basically navigates using all the session manager and the MCP manager that is going to help us to understand how these tools are being used. And then we are going to see how the overall agent is going to answer using the right tool for this job. So if we look into the first query, what is SAP current stock price? The agent has decided to use the first tool, get the stock quote, and precisely get the actual value of the current stock price. But then when we jump into the document analysis workflow, we can see that he has decided to use a slightly different tool for the analysis sentiment. In this case, the second tool is going to be the Analyze Financial Report. And he's going to present a sentiment analysis, which is strongly positive for the SAP stock. And finally, we are going to have the testing analytics workflow, which is going to create this trend analysis. And for the third tool that is going to be used, it is going to be using the create trend analysis tool. And for all of these results, you can see that it's creating a comprehensive solution that contains all the different requirements for an expert analyst that usually does. So even it includes some disclaimers. So you understand that there are some considerations that you need to have before taking the recommendations. And finally, let's jump into the most interesting part of this demo, which is the multi-service financial intelligence workflow. What we are trying to achieve here is creating a complex query to our agent that requires several tools at the same time and use the answers from the previous tool as an input to the next one. So in this case, we want a comprehensive investment analysis for SAP, and we want from this current stock performance with specific metrics, analysis of recent financial sentiment, risk assessment, recommendations for investment, and of course, an analysis report at the end. Okay, as we see here, we can see that the agent is extracting all these different information using different tools for the job, and then using that previous information to the next tool in order to be as accurate as possible to fulfill the request that I just gave. And finally, once he has completed all the requests, he's going to create an executive summary with a detailed analysis on how to proceed for investment. And of course, not only that, but at the end, he's going to do an investment recommendation with some specific disclaimer and a final executive summary that can be shared across all these specific teams in your company. As you can see, the orchestration has been done across all these 3 different MCP servers using our specialized agent. This is something that will be used for you or for your team as a blueprint to create for other type of fields or for other type of problem statements, a full end-to-end orchestration. And with that, please don't forget to visit our Building Agents with SAP Generative AI workshop that all colleagues from AWS can help your team to run and execute on your site. And of course, to get all the code that we have presented today, you can access the workshop GitHub repo that is also displayed here. Thank you very much for this session.